So identifying angles, which angles are acute angles? So out of these, as we said, an acute angle, let's go back for the recording purposes. An acute angle is less than 90 degrees. Um, obtuse are greater than 90 but less than 180, and reflex are greater than 180 but so in this case, an acute angle, what's less than 90 degrees is this, this, and this. Um, an obtuse angle greater than 90 but less than 180. So this, and that's it. It should be. Sorry, 1 second. Obtuse and reflex are the remaining. Because they are greater than 180. How do I roll this up? Um, measuring angle. So we use a protractor to measure angle. This is shown in the diagram below. So as you can see, that would be an acute angle and it would be around 34 degrees because it is just above 30 below the 5 mark. So it is 35. Sorry, oh yeah, it's 35 degrees on the 5 mark. If you look 30, 31, 32, 33, 34, and from 35. Choose angles pretty similar again. 0 go here. This will be 140 as it is on the 140 mark. Mm, mm. And we know that it's 140 and not 40 because this is an obtuse angle and that means it is bigger than 90 but less than 180. So you look at the bottom number, which is 140 here. Compass directions. We also use angles to show directions. This is shown below with north N for north, E for east, and E for northeast. Turning from north to south is 180 80 degrees clockwise or anti-clockwise. Turning from northeast to southeast is 90 degrees clockwise. Turning from northeast to east is 45 degrees or 300 degrees anti-clockwise. So anti-clockwise would be that way. So that would be 315 degrees. I'll just draw it to show you what it would be like. So anti-clockwise would be this way. That would be 315 degrees. Whereas clockwise would be this way, which is 45 degrees. 45. Cool. Yeah. So now, no, that a full turn is 360 degrees, so half a turn is 180 degree and a quarter turn is 90 degree. This is a right angle. If you move from east to northeast in an anti-clockwise direction, you move through half of 90 degrees, so that is 45 degrees. So east to northeast in an anti-clockwise direction is that way, which would be 45 degrees. Examples. So what angle do you turn through? what angle do you turn through if you turn anti-clockwise from facing north to southwest? So anti-clockwise is this way. I'll just get my pen out. Um, thicker. Um, so anti-clockwise from north to southwest, did it say? Yep. So from north to southwest is this way. So it would be from there to there. Now to work this out, you would do so there to there is 90 degrees, and there to there is half of 90 degrees, which is 45 degrees. So we would do 90 at 45, 90 plus 45 is equals 135. So the answer will be 135 degrees. Yeah. So south to southwest again. If we get south to southwest, sorry, erase that. South to southwest would be um it's anti-clockwise, so this line's already drawn. It would be from here all the way to there. So that would be 90 degrees, 180 degrees, 270 degrees, add 45. So that would be 315 degrees, guys. So the answer would be for this 3, 1, 5. Let me just erase this. So the answer would be 305 degrees. I can check that now. Yeah, cool. Then northeast to southeast. Again, northeast to southeast, anti-clockwise. Let's get the erase northeast to southeast. So from there all the way to there, which would be, let's work this out. 90 degrees, 180 degrees, and 270 degrees. So the answer would be 270 degrees, guys. Yeah, perfect. So measure of central frequency, mean, median, and mode are all different ways of describing the average for a set of data. To find the mean, you add up all the numbers and divide by the number of numbers. This gives what is usually meant as the average. To find the median, you place all the numbers in order and select the middle one. This gives you a sample value as another average. To find the mode, you find the value that occurs most often. This is yet another way of demonstrating the average. You may have met these terms before, but we will recap the methods of calculating each one with the simple data sets. So, mean this mark the marks below were obtained by students on a math test that was marked out at 20. To find the mean of this set of data, we add up all the marks and divide by the total number of students. So to do this, there were 15 students. As we know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there were 15 students. If we add them all up together, it's 180 divided by 15, which equals 12. We'll get our calculator out for this. Um, so, it's clearer to you guys. So the mean of the set of data is 12. To find the median, we put all the values in order and find the middle value. So 7, 8, 9, 10, 10, 11, 11, 12, 12, 12, 13, 14, 15, 17. So if there are 15, we want to find out what is the eighth number, I think so. 1, 2, 3, 4, 5, 6, 7, 8. So the middle would be this, sorry, the seventh number. There 1, 2, 3, 4, 5, 6, 7 before the eighth number, sorry, and 1, 3, 4, 5, 6, 7. So the median would be this number, guys. Yep, exactly that number, which is 12. Note that there are 7 values to the left of this and 7 values to the right of this, so the median of this set of data is 12. So the mode of this set of data, the mode is the most common value that occurs, the value that occurs the most frequently. So in this case, the value that occurs most frequently, again, is 12, guys. So the answer will be 12. You can see that the mean mode and median are all equal to 12. However, this is not always the case. The mode is not strictly a measure of the central tendency, but is included here with other averages. Hmm. Here are the goals scored by Manchester City in the second half of the season 2018 to 19. So 1, 2, 3, 0, 2, 3, 4, 3, 6. So if we count how many there are here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19 games have been played. So to work out the mean, we add them all together. So we do 1 plus 2 plus 3 plus 0. I'll just show you what I'm doing here. Plus 0 plus 2 plus 3 plus 4 plus 3 plus 6. 4 plus 3 plus 6 plus 1 plus 5 plus 0 plus 2 plus 5 plus 3 plus 2
He's using calculator himself.
um, plus 2 plus 1 plus 6 plus 2 is equals 51 goals. 51 goals. Um, 51 divided by 19. 19 equals 19 to 51 divided by 19. Don't think I've done that right. Well, so 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 2 is 8, 8 plus 3 is 11, plus 4 is 15, 15 plus 3 is 18, 18 plus 6 is 24. 24 plus 1, 25, 25, 30, 32, 37, 40, 42, 43, 49, 51. That's right. So the answer is 2.68 to 2 decimal places. 6.
My tires, my tires, my friend tires. Every single one.
Guys, can we not unmute ourselves, please? Because it just puts the volume loud. Um, sorry, it's meant to be 8. It keeps doing this. Oh my god. Anyways, you know what I mean. It's 8 or 2.7 to 1 decimal place. Yep, 2.7 to 1 decimal place, as I said. That's to find out the mean. Um, So then find out the median when you put them in order, and to find out the middle one if you want. So 1, 2, 3, 5, 6, 7, 8, 9 before it. 1, 2, 3, 5, 6, 7, 8, 9 after it. So the median is 2, and the mode, which is the most frequent, is 2 again, as 2, 2, 5 times. So for this data, the mean is 2.7, the median is 2, and the mode is 2 as well. Calculate the mean, median, and mode for the goals scored in the first half of the season. So again, for the first half of the season, there will be 19 games. Again, 4 plus 1 plus 1, which is 6, 8, 9, 10, 10, sorry, 6, 8, 9, 10, 12, 14, 17, 18, 19, 25, 27, 30, 31, 34, 37, 39, 42 goals scored. So it'd just be 42 divided by 19, which equals divided by 19, which is 2.2 to 1 decimal place. So working out probability. Probability describes mathematically how likely it is an event will happen. We can express probability on a scale of 0 and to 1 as shown below. So 0 is non impossible. Between 0 and half is unlikely. Half is an even chance, and between half and 1 is likely, and 100 or 1 is certain. So your birthday is tomorrow, is probably unlikely. It will rain sometime this year in Manchester, is probably certain. The sun will shine tomorrow, is probably an even chance, as is that the sun already. Um, the events A, B, C, and D have probabilities as shown below. Now answer these questions. Which event is most likely to occur? It is A, as it's closest to 1. Please stay on mute. Which event is most unlikely to occur? Is D, as it's closest to 0. Which events are more likely to occur than event B, C, and A, as they are further past B, closer to 1? And which events are less likely to occur than event A, C, B, and D, as they are less than A and closer to 0 than A. Um, D, B, and C. Equally likely outcomes, coins, and dice. When tossing a fair coin, There is an equal chance of obtaining head or a tail. We call this an even chance, and the probability will be half. That is half as a fraction, or zero point 0.5 as a decimal, or 50% as a percentage. When throwing a dice, there are six possible outcomes. That is 1, 2, 3, 4, 5, and 6, and each one has an equal chance. What is the probability of throwing a 6? So it would be 1 out of 6, because there are six possible outcomes and there's one outcome of a 6 coming. What is the probability of throwing a 1 or a 2? There's two chances there out of 6, so it'd be 2 out of 6, which simplifies to 1 out of 3, 1 over 3. Um, yeah, probabilities playing cards. Now see if you can answer these probabilities questions. Check your answers for each question. If you take out one card at random, what is the probability of getting a red card? So there are 13 red cards. I think, out of 52. So it'd be 13 over 52. Oh, 26, sorry. Yeah, because there are hearts and diamonds. So 26 over 52, which is a heart. What are the chances of getting a spade? That is 13 over 52, which is a quarter. What is the chance of getting a picture card? So Jack, Queen, or King? There are 3 times 4, which is 12 over 52. Um, so that is 3 over 13. Probability of combining, and we are now ready to move on to finding probability of combined events. Take 2 dice and throw them together, adding up the total scored. What are the lowest and highest totals you can get? So the lowest total is 2, as 1 is the lowest number, and you're throwing 2 dice, and the highest number is 12, as 6 is the highest number, and you're throwing 2 dice. So, as I said, 2 and 12. We can call we can use what we call two-way table to illustrate the possible scores as the expected frequency. So 1 at 1, 2, 1 at 2, 3, 1 at 3, 4, 1 at 4, 5, 1 at 5, 6, 1 at 5, 7, and so on for the rest. You just add this by this, or that by that, or and so on. This table shows the complete set of outcomes. You can see that the number that occurs most frequently is 7. As you can see, 7 occurs 1, 2, 4, 5, 6 times, which is the most. And the least frequently number is 2 or 12, which only occurs once. We summarize the frequency by looking at the number of times each total occurs along the diagonal. So probability of combined events, we summarize the frequency by looking at the number of times each total is scored along the diagonal. We can use this table to work out probabilities for each number possible. So this is calculated using the following formula, which is probability of an event. Sorry, the probability of an event equals to the number of successful outcomes over the total number of outcomes. So what is the probability of throwing a total of 8 with 2 dice? Total of 8 with 2 dice is 5. So the number of successful outcomes is 5 over the total number of outcomes, which is 1 and 2 and 3. So 1 and 2 and 3 is 6, and 4 is 10, and 5 is 15, and 6 is 21, and 5 is 26, and 4 is 30, 33, 35, 36. So it would be 5 over 36. I think, yeah, exactly. So we could write that P8, so the probability of A is 5 over 36. We are now in a position to work out the probabilities for each number, for each score, and add them to the table. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So What is the probability of scoring a 6, 7, or 8? So scoring a 6 is 5, a 7 is 6, and a 8 is 5. So we would do 5 add 6, which is 11 add 5, which is 16 over 36, um, which can be simplified to 4 over 9. Two coins are tossed together. What is the probability that they both land heads up? Use a two-way table to help you find your answer. So first coin head head. So the probability here is clearly to get two heads is 1/4. So it's just telling you that yeah, only one of the outcome gives us two heads. So the probability of getting two heads when the coins are tossed is 1/4. Probability of combined events using a tree diagram. Two coins are tossed together. What is the probability that both land heads up? This time we will use a tree diagram to solve this problem. Again, so using a tree diagram. First one is heads. The second one is head and tails. Third one is tails and heads, and the fourth one is tails and tails. So we see one outcome is double head, so there would be 1/4. What's the probability of getting one head when two coins are tossed? Sorry. So the probability of getting one head is 1, 2, and 3. So it'd be 3/4. No, that's wrong. Sorry, guys, because probability of getting one head is clearly 3 here. 1, 2, 3. So it'd be 3/4, not a half. Um, it'd be 1/4, 1/4, 1/4. We can summarize these measures of central tendency in the box below. So mean is sum of values or the number of values. Median is the middle value when the data is arranged in order. And there are two central values. Me the median is the mean, and the mode is the most common value. We define the range as the difference between the largest and smallest values. So last year, during 1 week of August, Jamal recorded the maximum daily temperatures in two cities. The results are shown in the table below. What is the range of temperatures in London and Edinburgh? So in London, the lowest value is is 22 and the highest value is 29. So the difference between that is 7. So for London, it would be 7. And for Edinburgh, the lowest value is 22 again, the highest is 26. So it'd be 4 as it says there. What is the mean temperature in London and Edinburgh? So in London, it'd be adding all them divided by 7. So it would be 22 at 25, which is 47 at 26, which is 73 at 24, which is 97, 97 at 24, which is 121, and 29, which is 150 at 28, which is 178 divided by 7. So it says give the answer to one decimal place. 178 divided by 7 to find out the mean, which is the average. It equals 25.4, and the second one is 23.7 because I've clicked it by accident. But to work it out, let's do it. So 22 at 22 is 44. At 23 to 67 at 24, which is L2.91 at 25, which is 116 at 24, which is 140 at 26, which is 166. 166 divided by 7, which equals 23.7 to 1 decimal place. What are the main differences in temperature between London and Edinburgh? London has a higher mean temperature than Edinburgh and also a larger range of temperatures. So that's just analyzing the data and writing what it is. So data frequency. The data is also often given in terms of frequency. For example, here is the data from pupils in a class giving the number of people living in their home. The frequency can refer to the number of people in that category as it does here, or the number of times an occurrence happens. Also calculating the mean, mode, and median from frequency tables. We need to find the mean, mode, and median for the data in the previous table. As 2 occurs twice and 3 occurs 9 times, we can calculate this as 2, 3 times 2 plus 9 times 3 plus 10 times 4. So, so to find out the mean, so it tells us, so all we do is multiply all of these and add them together. So 2 times 3, which is 6, 3 times more, which is and so if we write this whilst we're doing it, work out the mean, so 6, sorry, uh, 6, 27, 40, and 18, sorry, 1 second, 18, sorry, it's 18, the, to write it like this, 18, 7, 8, 8, 0, and 10. So when we add them all together, we would get, sorry, add them all together. Uh, uh, that'd be 6 at 27, 33 at 40, 73 at 10, 83 at 18, 83 at 18, which is 101 at 708 at 8, 102. I'm trying to figure this out. 108 at 8, 116 at 10, 23. So let's see how they've done it. One second. So that's 3 times 2, 6, at 27, at 40, at 10, at 30, 30, at 7, at 8, at 10. So mode, 1 second. All right. It says 3 here, but they've set it to be 5, which I don't understand because it says 6 and 3 times, but here it says 6 and 5 times. So if you were taking this data, it would be 138, but if you were taking the data I said, it would be 12 less, which is 126. And the total number of entries is 30 if we add them together, so it would be 126, not 138, 126. 1, 2, 6 divided by 30, which equals 1, 2, 6 divided by 30, so the answer would be 4.2 guy. 4.2 would be the answer for this. So the mode, this is straightforward, as the value 4 is a hack of highest frequency. So the mode is 4. And the median, there are 30 values, so we need to find the average, which of the 15th and 16th value, we could write it all out in numbers, but it's easy to note that 2 occurs 3 times and 3 occurs 9 times, so there are 12 values for 2 and 3, and 4 occurs 10 times. It is clear that the 15th and 16th value would be 4, so the median value is 4, because 4 and 4 is 8 divided by 2, which is 4. Data. Sometimes data is not exact. Sorry. Um, so sometimes data is not exact and is collated into ranges of values. We cannot find the mean exactly, but we can estimate it as we see in this next example. The table below shows the number of days that children in one class in a school were off sick in 1 year. What is the mean number of days off per child? So again, 125 is 12, 6 to 9, 6 to 10 is 9, 11 to 15 is 6. So number of days to 15 is 6. But 3. To estimate the mean, we have to assume that in each group, the average number of days is the middle of the group. So we often call this the midpoint. This is because from how the data is presented, we don't know the exact number of days each individual was sick. We can calculate this an estimate for the mean as shown below. So 1 to 5, the midpoint is 3, 6 to 10, the midpoint is 8, 11 to 15, the midpoint is 13, 6 to 16 to 20, the midpoint is 18, and the last one, the midpoint is 23. So if we add them all if we times these, 12 times 3 is 36, 8 times 9 is 72, 13 times 6 is 78, 18 times 3 is 54, and 23 times 2 is 46. So if you add them the midpoint. I mean, if we add them together, we get 286 divided by 32, which is 8.9 days to one decimal place. So scatter diagrams are used to compare two sets of data in order to see if there are any links or link between them. It is said that a person's arm span, the distance which is the distance from fingertip to fingertip. Um, when their arms are extended to the side at right angle to their body and parallel to the ground, is very close to their height. Um, look at the data from a year rated group of secondary school learners on the scatter diagram, right? Each point is a pupil's arm span plotted against their height in order to test the claim made above. The various data points are marked on the diagram to enable us to see how they relate to one another. This just seems to indicate that there is evidence to support this idea. You say that the two quantities, arm span and height, are positively correlated. Some quantities do not have a positive correlation. See the graph below that shows the relationship in a vocabulary test for a group of Year 6 learners between time spent revising and number of wrong answers. So the arrangement of the points on the scatter graph suggests a strong negative correlation because it is going up from right to left. The probability, the prob, there would be there would probably be positive correlation between the number of right answers and times. And rising correlation is a measure of how closely the two sets of data are linked. So in this example, it's negative correlation because you can see the points are going this way from the first point to the second point, and they're all equally distributed. However, if the points were going that way, it would be positive correlation. Um,
Oh,
Description of correlation. So, like I said, strong negative correlation is that way. Negative correlation is still that way, but it's got more scattered points. This has no correlation as it's not going either that way or that way. They're all scattered all over the place. This is a weak positive correlation as it's going from left to right positively, and this is a strong one as what points are closer together. Values that is outside the normal range of data is called an outlier. For example, this would be a strong positive correlation. However, there could be a value here. So if there was one value there, we would call it an outlier. But however, if there were several values scattered all over the place, like there, I'll just draw them as dots there, then it would be no correlation. But if there's just one, it would be called strong positive correlation with a negative, with an outlier, sorry. Scatter diagram in context. So, is there a connection between ice cream sales and temperature? Draw a scatter diagram to show these data, then decide whether or not there is a connection between the ice cream sales and the temperature. So, if we are drawing a diagram, the points would be plotted like this. For example, on 20 degrees is 294 and then 289 as well. So as we can see here, the points are close together and going up diagonally from left to right. So we would say this is a strong positive correlation as the points are quite close together as well. Um, sorry, scatter graph for this data clearly shows that there's positive correlation as all the data points are between the two straight lines that enclose all the points. We can also draw a line of best fit to show here in red. So if we rub the line out, draw, which is what I am drawing actually, and that's the line of best fit. Um, that is as close as possible to all the points, and use this as an indication of a correlation between them. So, you guys of today, that is it for the lesson. You guys have completed the module. Angles, mean, median, mode, probability, and scatter diagrams. Now, practice your skills with the activities and test your progress with the knowledge check. Um, I think that is it. Yeah, cool. So I will stop sharing my screen and stop the recording now. If you guys have any questions, please let me know. Otherwise, you guys are free to go, and I will speak to you tomorrow. Thank you, guys.
Thank you.
A lot.
Thank you.
Thank you.
Thank you.
Thank you. A couple more minutes if you guys have any questions, and then I'll have in the meeting.
Yeah, hello.
Hi.
I'll go when you send the recording. I think I will have to revisit the probability because I didn't really get how it's been done. So I
Okay,
didn't really
I
understand
can
it
help
very
you
well.
if you want me to go through it quick. I can help you if that helps you. Um, I don't know. I
Okay,
can.
that will be fine. That will be fine. Thank you.
Yeah, give me 1 second. I'll share my screen. And if there's anything you don't understand, just please let me know, and I'll go through it again. So if I share my screen, so like I said, you can read this as it's normal. So in probability, 0% is impossible, 100% is certain, half is obviously an even chance, and then anything between zero and half is unlikely, and anything past half and below one is likely. So, for example, your birthday is 1 day out of 365 days in a year. So that means the chance is 1 out of 365, which means that it is very unlikely to happen tomorrow, if you understand what I mean. Um, it will rain sometime this year in Manchester, so there are 365 days in a year, and there's always a 1 out of 2 chance in a day for it to rain. So it would be 50% chance in a day. However, in a year, it would be 50% chance every day. So it would be quite certain that it would rain one day out of 365 days. The sun will shine tomorrow, so tomorrow there's half a chance if it was either rain or if it, I mean, there's half a chance if it would, the sun would come out or if it would not come out. So it would be 50% chance. Again, this is just asking us what is most likely, so how to read this number line. So which event is most likely to occur? We want to see which event is the closest to 1, which is A. So that would be the most likely to occur. Which is the least likely to occur or most unlikely to occur, which is the closest to 0, which is D. So that would be the most unlikely to occur. Again, which events are most likely to occur than event B? We would check what is closer to 1 than B, which is C and A. So that would be the answer. And which events are less likely to occur than A? So A is closest to 1. So we want to see what is less than A, closer to 0, which is D, B, and C. Now, this is telling us when tossing a fair coin, there's an equal chance of obtaining a head or a tail. We can call this an even chance, and the probability will be a half. So, as there are only a head or a tail on an even coin, there's two probabilities and 1 out of 2 So we can either get head or tail, so it would be half. It would be 1 out of 2 chance for us to get that. And when throwing a dice, there are 6 possible numbers on a dice. So to get one number, which is 6, so what's the probability of scoring 6? It would be 1 out of 6 numbers. Again, probability of scoring a 1 or a 2, there's 2 numbers there out of the 6 possible outcomes, so it would be 2 over 6, and this simplifies to 1 over 3. Playing card. Now see if you can answer these probability questions, check your answers for each question. So if you take out, by the way, if you got any questions, just stop me in between, so I can explain it properly. If you take out one card at random, what is the probability of getting a red card? So in cards, if you know, there are 4 suits, 2 suits of red and 2 suits of black. Now, each suit has 13 cards because there are a total of 52 cards in a deck. Each suit has 13 cards. So I said there's 2 suits of red, so 13 times 2 is 26. So there would be a chance of 26 cards being red out of 52, which is half a chance. This simplifies to half. Again, spade is 1 suit. So 1 suit, as I said, has 13 cards, 13 over the 52 total cards, which is 1 over 4. It simplifies to. But a picture card is either Jack, Queen, or King. So there are 3 in each suit, as I said. So there are 4 suits. So we times 3 by 4, which is 12 over the 52 cards, which is 12 over 52. This can simplify to 3 over 13. This is something we did in fractions to simplify them. Probability of combined events. So take 2 dice and throw them together and add the total score. What are the lowest and highest scores you can get? It would be clear that not all totals are likely to occur, and the lowest would be 2 because because the lowest total, so the lowest number is 1 on a dice. So they said we're throwing 2 dice, so 1 add 2 on a die, sorry, and we're throwing 2 dice, which is 1 add, I mean, 2 times 1, which equals 2. And again, the highest number is 6. We are throwing 2 dice, so it would be 6 times 2, which is 12. We can use the two-way table. So a two-way table is basically showing the possible outcomes on the dice, which is 1, 2, 3, 4, 5, 6 on each dice from left. And all you do is just add these. So here to get this answer, you would do 2, add 2. You would do 2, add 1. You would do 2, add 3, and so on to write a graph of this table. So again, it just shows what the most frequently answered. So to work out the most frequently answered, you look diagonal. So here, diagonally, 6 times 7 comes, and nothing more than 6 times. So the most frequent would be 7 here. Again, combined events, we summarize the frequency by looking at the number of times each total occurs along the diagonal. We can use this table to work out the probability. So it's got this frequency on this table behind. So 2 occurs once, 3 occurs 2 times, 4 occurs 3 times, 5 occurs 4 times, 6 occurs 5 times, 7 occurs 6 times, and so on. 8 occurs 5 times, 9 occurs 4 times, 10 occurs 3 times, 11 occurs 2 times, and 12 occurs 1 time. Again, that's exactly what I said in the last one. So we can use this out to work out the probability of each number. So the probability of an event is the number of successful outcomes over the total number of outcomes. So what is the probability of throwing a total of 8? So it says eight, a total of eight, we can throw five times. So the number of successful outcomes would be five. The total number of outcomes is adding all these together, which is one, add two, add three, add four, add five, add six, add five, add four, add three, add two, add one. Once we add them together, we get 36. So the answer would be five, the successful outcomes, over 36, which is the total number of outcomes. So the total answer would be 5 over 36. Again, now this is telling us again the same thing. It's just telling us the probability, and all it's asking here is what is the probability of scoring a 6, 7, or 8. So all we do is add 5, add 6, add 5, which equals 16 over 36. So all we're doing here is combining them and adding them together and working out the probability. So 16 over 36 equals 4 over 9. Again, two base coins. So these are equal coins. And to find the probability here, again, you do a two-way table to see what you can get. So you can get a double head, you can get heads or tails, you can get tails or head, or you can get a double tail. So from the table, we can see that there are four possible equally likely outcomes. So it's just telling you what's in the table. Head twice can come once. Tail, head and tail can come twice, and double tail can come once. So the probability of getting two heads, if we look at this table, two heads only come once out of the four. So the answer is 1 over 4. So here again, it's a similar thing to the table. However, we just do a tree here. So to work out here, you follow that. That's double head. That's head or tail. This is tail or head, and that is double tail. So again, it's telling you the same thing here. The possibility of getting a double head is one, because you can't get another double head out of four. So what is the possibility of getting one head when two coins are tossed? So of getting one head when two coins are tossed is 1/4 and 1/4. So it will just be adding them together, which is 2/4. Simplify that is a half. So we can summarize these measures of central tendency. So yeah, that's pretty much the probability section. Have you got any
Okay.
questions?
Um, I understand. Is okay now. Yeah, it's clear.
Are
It's
you
clear.
sure?
Yes, thank you very much. Yeah.
No worries. If you
And
got
you're
any
going to
questions,
send the recording for us, right?
yeah, I'm going to send this either today or I'll send it tomorrow. If you got any
Mm,
questions once you rewatch it, just ask me in the group chat
mm.
or you can ask me next week or tomorrow. I'll send
Okay.
I'll send the recording now actually, so you can go over it.
Yes, okay. Thank you very much. Thank
You're
you.
welcome. Thanks a lot. Thank you guys.
Okay. All right. Bye-bye.
Please.